and we're going to go into our flattener view. And again, what I just want to relate back to is the problem that we are solving right now is how to create your initial patterns. You can see that we have a 3D model view on the left, and we have a 2D pattern view on the right. Those are our initial flat patterns based on a fracture algorithm. And the color code that you see here is based on the initial mesh that we're given from SOLIDWORKS. We're actually going through a remeshing process right now, and this is a process to create a mesh that is going to be used for our subsequent simulation. The simulation is going to simulate the fabric stretch. So this is exactly what a master pattern maker would do. They would get the pattern pieces, they would throw them over a 3D form, and they would look for areas of stress and areas of sag or wrinkles, and they would try to eliminate them. And we start our simulation by providing an analysis mesh. The analysis mesh is used for the mathematics that go into eliminate the stress and sag here. And you can see it takes a couple of minutes. You get a status complete there in the second column. Here we go, to see on the remeshing process. And now what we do is we take the updated model and we start the process to optimize the pattern pieces. So you'll see if we zoom in here on the 2D side of things, the pattern pieces are actually being redrawn. We can just go in a little bit closer there. Yeah, let's just click on the toe piece there just for so we can, yeah, there we go. So this toe piece here, the pattern pieces are actually deforming themselves. The polygons themselves are being deformed and manipulated in such a way to eliminate the stress, to eliminate the sag, and lastly, maintain these edge relationships. Depending on the complexity of your model, this will be an extremely fast process, or it'll take a little bit longer. So you can see that if we go to our pattern status, most of our pieces are complete, and we've got 2 pieces that are still to come, and these pieces are the ones with less formable surfaces. So these are surfaces which are more complex in their shape. Now we do support multi-threading. The process that you're looking at here, for example, if you're working on a computer with multi-cores, this will go faster because we will partition out the analysis, the mathematical tasks to different processors. The particular laptop we're working on today is nothing special. We're working on a Lenovo laptop with about 32 gig of RAM. Certainly not a blazing fast CAD machine. It's a machine that's you would expect to find for anyone doing work that requires some portability. And you can see that we've got all the pieces complete now except for the one. And we're just going to stop the optimization here. And we could let this run a little bit longer, but we're going to stop it here just to continue on with our demo. Okay, what we're doing right now is we're going to update our edge geometry. The edge pieces have changed, and so this is a rebuilding process that's going to just update those pieces. And the last step is to rebuild our product in SOLIDWORKS.